Hey, today I'm going to do lab for my cloud security class. And this is the lab Managing Network Security in the Cloud. Introduction, reconnect. Traditional network security involves protecting on-premise or internal networks from attacks and exfiltration. An internal network presents a simpler set of requirements because everything on the internal network is fairly easy to identify as trusted. Generally, traditional network security uses firewalls and intrusion detection prevention solutions to identify untrusted external network access. However, as remote and hybrid workspaces have become more necessary and popularized, enterprises have encountered new challenges regarding how to secure their networks when dealing with remote employees and cloud based vendors. Although the vendors of the cloud resources share some responsibility for security management, is often difficult when dealing with multiple vendors who all have different management expectations. Cloud computing has brought a great deal of benefit to both large and small scale organizations. Primarily, organizations can now scale their infrastructure without incurring high capital costs. They can hire more employees without needing to increase their physical infrastructure. They can also expand their services and product development by leveraging cloud based solutions, which can often be cheaper and less of a demand on the physical infrastructure. For this reason, network security professionals should be aware of the two major methods of managing cloud network security: virtual networks and zero trust models. A virtual network is used by professionals to essentially define a perimeter by creating a virtual network among the cloud resources and using firewalls to protect the perimeter. Zero trust fundamentally operates as if there are no perimeters, meaning there is no such thing as an internal trusted network regardless of the physical setup of the network. Under zero trust, all networks are hostile. There are always threats, and it is essential to authorize and authenticate everything. Your company is moving its web services to run on cloud based machines. To minimize vendor lock in when a client must use a vendor because switching to another is too costly, your architecture uses a private Docker registry for holding production code, images, and runs services as Docker images on virtual instances from various cloud providers. This does not require any advanced provider features, and most providers have a method of running customer managed virtual instances. However, this means all traffic is over the public internet. In this lab, you will be focusing on implementing a zero trust model in which every cloud resource will implement strict access controls. Lab overview. This lab has three parts which should be completed in the order specified. In the first part of the lab, you will use OpenSSL to create X509 certificates for using mutual TLS among the components of the network. Second, in the second part of the lab, you will configure a Docker registry and client to use mutual TLS. In the third part of the lab, you will configure a front end web server and an origin web server to use mutual TLS to secure their communication channel. Finally, you will explore the virtual environment on your own. You will answer questions and complete challenges that allow you to use the skills you learned in the lab to conduct independent, unguided work similar to what you will encounter in a real world simulation situation. Learning objectives. Upon completing this lab, you will learn explain how the zero trust model can be used to secure cloud networks, create X509 certificates for mutual TLS, enable mutual TLS for protecting Docker registries, enable mutual TLS for protecting original servers topology. This lab contains the following virtual machines. Please refer to the network topology diagram below. Virtual workstation, security server, pfSense, Docker server, Docker runner. Security server, virtual workstation, LAN, pfSense, demilitarized zone, Docker runner, Docker server. Tools and software. The following software and or utilities are required to complete this lab. Nginx, Docker, OpenSSL. A lab report file including screen captures of the following. At least the 12 lines of the output for the root certificate, the X509V extension of the registry certificate, the unknown certificate authority, the bad certificate error, a successful pull of registry 5000 alpine on Docker runner, the running front end and back end containers, the successful page load from app, HTTP without mutual TLS, transport layer security, the unsuccessful page load from origin, challenge analysis, lab report file including screen cap. Okay. Okay. Um, introduction. Okay. Part one. Oh my God, it's a lot of reading. If necessary, okay, log in. We are logged in. On the virtual workstation desktop, double click on command prompt icon to open the command prompt type SSH security server. Security server. Press enter. Welcome to Ubuntu. Documentation, system processes. Ubuntu comes with absolutely no warranty to the extent permitted by applicable law. Okay, we are in Ubuntu now. You should see a shell prompt for user SecServer. Windows has OpenSSH installed by default. The team has set up the machines to use SSH keepers for authentication, so no passwords are needed for connecting. They also created a configuration file to ease the process. At the command prompt, type cd.ca. So change directory to ca. Okay, now we are in the ca. cd command. At the command prompt, type ls to display what's inside. There are 5 files listed. The 4 extension files contain options for OpenSSL that will be used when signing certificates. The details will be discussed later. The script contains commands to create a certificate. Before using the script, you will create some certificates manually. The first step is to create the private key for the root certificate of your certificate authority. In the command prompt, type OpenSSL gen key hyphen algorithm RSA pk opt. Then RSA keygen bits 4096 out ca dot key. Okay, there is some error. OpenSSL gen pk algorithm hn RSA pk opt RSA k gen. Okay, kgen and here. Okay, I see. Kgen. Ah, come on. Okay, now kgen bits. Okay. This program has many uses. One of those is creating keys. The arguments used in the previous command are the following. Gen pk is the open SSL subcommand that indicates you want to create a private key. Algorithm RSA specifies the private key should be generated using the RSA algorithm. Generate an RSA private key. pk opt RSA keygen bits 4096 indicates the number of bits to use for the key. Today, 2022, 2048 bits is a reasonable size for RSA keys for production server certificates. However, a certificate authority key will typically have a longer life, so using a larger key size for longer term security is warranted. Out CA key specifies the name of the file to be used for the private key, while only one file is generated. Both the private key and the public key can be determined from the file. Since the file contains the private key, it must be protected. This file will be generated with 0600 permissions, read and write for the owner only. To help with this protection, for simplicity, you have not included a password to protect this key. In a real production system, the root certificate key would need to be well protected. Okay, at the command prompt, type open SSL rec space hyphen new space key ca key subject cn example ca. Wait, days 100 out ca cert unrecognized flags. Okay, that's a mistake. non-positive number. Oh, okay. This command combines two steps in the typical process of creating an X509 certificate. The first step is to create a certificate request. The second step is creating a certificate and signing it based on the request using the certificate authority key. For the root certificate, the same key is used to create the request and to sign it. For this reason, a root certificate may also be referred to as a self-signed certificate. The individual arguments are as follows. Rec is the OpenSSL subcommand to generate a request. New indicates that the new certificate requests should be created. Key CA key specifies the key to use for the request. Sub apostrophe forward slash CN equals example CA sets quotation mark sets the distinguished name for the request. Hyphen X 509 indicates that the request should be signed using the same key used for the request. Effectively, this indicates the output should be a self-signed certificate instead of a certificate request. SHA 256 specifies the hash that should be used as a part of the signing process. Hyphen days 100 gives the number of days the certificate should be considered valid from the current date. Out CA dot CRT gives the name of the file for the resulting certificate. File is not human readable. For X509 certificates, there is a very specific encoding process that is used to create a sequence of bytes to represent the certificate. To inspect the contents of a certificate, you can use another subcommand of OpenSSL. Okay, now again, type OpenSSL X509 no out hyphen text in CA CRT. Okay, this is some hash algorithm signature. See the certificate contents. Yeah, it's not human readable for sure. Algorithm. The output shows the details of the certificate is in a human readable form when possible. Some of the fields are essentially big integers, which are shown using a hexadecimal, or base 16 encoding. The certificate makes the claim that the distinguished name given by the subject field is linked to the public key given by the subject public key in info field for the time span indicated by the validity field. This claim is signed as being valid by the issuer using the issuer's private key. Farther down in the output of the command is a section called X509 version 3 extensions. This section can contain additional constraints or information the signing certificate authority is placing on the certificate. This root certificate contains three extensions, which OpenSSL includes by default for new CAs. Subject key identifier, a hash of the public key of the subject of the certificate, authority key identifier, a hash of the public key of the issuer of the certificate. Basic constraints specify if this is a CA. Do I have some time that I have to finish this lab, or this is no time? No. Okay, let's see. So, subject key identifier SKI, a unique ID hash made from the subject's public key, helps identify the certificate's key. Authority key identifier AKI, a unique ID hash made from the issuers, a public key used to link a certificate to the CA that sign it. Basic constraints defines whether the certificate is a certificate authority CA and and can issue other certificates or just an end entity certificate. In short, SKI, my key, AKI, who signed me, okay, and basic constraints, am I certificate authority or not? My key, who signed me, basic constraints. Okay, okay, next. Type OpenSSL Gen PK algorithm RSA PK opt space RSA underscore key gen bits colon for 2048 hyphen out registry key. Okay, here you have used a command similar to the one of the CA key. A server certificate will typically have a shorter lifespan than a certificate authority, so using a 2048-bit key is reasonable. At the command prompt, type OpenSSL reg new key registry key subj cn registry registry out registry CSR. Okay. Now process is split into two steps. First, the request is created as you have just done above. Then it is signed by the certificate authority. The arguments used for the request command are the same as those used to create the self-signed root certificate. However, The extra arguments about signing are not included. Those will be included in the command to sign the request. OpenSSL X59 request in registry CSR key key set serial 01 days 10 next extension file registry x 256 out registry setting. Okay. The X509 subcommand also used for signing requests. The arguments are the following. X509 is the subcommand to use. Request indicates that the certificate request will be provided as input. In registry, CSR specifies the input certificate request file. CACACRT gives the certificate to be used as the issuer. CA key gives the key file corresponding to the issuer certificate. Set serial 01 indicates the serial number to use for the generated certificate. Extension file registry gives a file containing the extensions to include in the certificate. The other arguments have the same meaning as the earlier command used to generate the self-signed or root certificate. Note that the lifespan here is shorter. The extensions file needs a little more explanation. Type cat registry extension. To read, right? Authority key identifier, key ID always, subject key identifier hash, basic constraints as a false. Okay. Authority key. What was that? The subject is my key. Authority key, who signed me? Key ID. Subject key is my key, right? That's what, okay, yeah. So its key is always who signed me. Yeah, subject key is hash, who signed me always, and CA false. So it's not certificate authority. Okay. Subject alternative name. Okay. Key usage. Do we have key usage here? Oh yes, we have key usage, digital signature, key encipherment, key usage intended uses for the certificate. The full details of this are outside the scope of this lab, but they are important in production system. Okay. Explain shortly. Sun. Subject alternative name. Adds extra identifiers for the subject like domain names, IP addresses, or emails. Key usage lists what the certificate's key can be used. So digital signature and key and cipherment. Cipherment. Okay. SKI and AKI provide ways to identify the keys used in a certificate. Subject alt name extension allows multiple names to be associated with a particular agent in addition to the distinguished name in the subject. Actually, the subject alternative name in the recommended location for all distinguished names on a certificate, as most browsers no longer consider the subject's singular common name CN as a valid identifier without a matching SEN entry in the corresponding section. You can add alternate identifiers of specific kinds, here a DNS name of registry and an IP address. At the command prompt, type OpenSSL. No out text in registry cert. Make a screenshot. Open SSL request new key RSA 2048 nodes key out cloud cloud1 key subject cn cloud one quotation mark out cloud one CSR. Writing new private key to cloud one key. Name is expected to be in the format type 0 value 0 type 1 value 1, where characters may be escaped by a backward slash. This name is not in a format CN cloud. Problems making certificate request. Is that correct? The following new arguments are used to generate. I will just check OpenSSL request new key RSA nodes key out cloud subject space. Okay. Here is the mistake. Just one mistake. One, but I will fix it. Okay. Now it's good. Notes indicates that the key file should not be password protected encrypted, referring to the data encryption standard DES algorithm. This option should be read as no DES. Okay. Data encryption standard DES. data encryption standard. Data encryption standard. Okay. When the command executes, you should see output similar to that for the key generation command. The next step is to sign the request as was done for the registry certificate. Be sure to use cert for the final certificate file extension because it will be needed later. At the command prompt, okay, open SSL X9 request in CSR CACR CA key CA key set serial 02 days 10 extension file cloud 1 extension share 256 out cloud 1 cert signature okay subject CN cloud 1 getting CA private key. CN stands for common name. Okay. Common name. Serial number is different. Excuse me, where is the serial number? Okay, here, 02. You will, the recommended practice for production system is to use random non-sequential numbers that are algorithmically, algorithm, algorithmically generated, algorithmical, algorithm, algorithmically, algorithmically generated. In this lab, you are using small integers for simplicity. You will also need keys for the web service front end and the web service backend. Next, you will create the certificates for each of these and sign them. A simple script has been created to simplify the process. Now, read the file. Right? Name 1, serial 2. If name, then echo invalid agent name. Exit 1. Fee means finish. Create the key. OpenSSL GenP algorithm. CN common name. Sign the request. 10 days. Okay. The script takes two parameters, a name and a serial number. If there is no file name extension, then file script will exit. This makes the script create and sign only requests for which a configuration has been created. Then the script uses three commands to generate the keeper, create the certificate request, and then sign the request, all which should look familiar. At the command prompt, okay, make cert sh front end 03 signature okay subject common name front end getting CA private key. Backend. Backend, same, everything the same. Key management is also a critical issue for private key infrastructure generally. The private key for a machine should be generated on the machine or using specialized hardware to protect keys. Then the certificate request can be sent to the certificate authority without sending the private key over any networks. Usually, there will also be at least one intermediate certificate authority used in the process. The root certificate authority will sign a certificate for the intermediate certificate authority, which can be done in a machine that is offline. Then the intermediate CA can be used on a network connected machine for signing agent certificates. It is possible for the chain of certificates to have more intermediates as well. Many organizations run into issues um, because of lack of proper tracking of certificates. Automated systems and standardizing your practices will go a long way in creating the right security protocols to avoid future breaches. Type logout. Okay, that was just part one. Part two. Enable zero trust Docker. Type SSH Docker server. Okay, we are in the Ubuntu. Now sudo Docker ps type password, container ID. Okay, image registry command entry point sh created 2 years ago. Up 44 minutes. Really? I'm doing this for 44 minutes? No way. Wow. Okay. Ports registry. I need to take a green tea. Okay. Okay. Hmm. Type sudo docker exec registry cat registry registry config yaml space config origin Okay. Okay. N config in memory blob descriptor. Let's ask explain each simply. Version 01 config the format version 2-4 log defines logging settings service registry. Logs will show the registry service name. Storage 5-9 storage where images are stored. Cache blob descriptor in memory. Cache image metadata in memory. Faster lookups. File system root directory. var lib library registry. Save image files on disk under variable library registry. HTTP settings for a server address. The registry listens on port 5000. Headers X content type options no sniff adds a security header to prevent browsers from guessing file types. Health Health check configuration. Storage driver check if storage works. Enable true. Health checks are turned on. Interval checks every 10 seconds. Threshold if 3 seconds. If 3 checks fail, it mark it unhealthy. This config sets up a Docker registry that stores images on disk, caches metadata in memory, runs on port 5000 with a security header, and has health checks to make sure storage is working. Okay. Okay. Line 9, root directory. Okay. Line 11, address. Okay, okay. Next. Cat and TLS YAML certificate certs registry CRT key certs registry key client CAS lines to entry give the files to use for the server certificate and key. Line 5 gives a certificate that can be used to verify client certificates. The paths used here must be paths that will be valid in the running container. Okay. Sed -e double quotation mark 13 R TLS yum config org config sed stream editor. Okay. To insert the contents to TLS, transport layer security, right? Or transport layer, yes, security. Okay. Now you need to retrieve the required certificates and keys that you created on SecServer in part 1. You will accomplish this using the SCP, secure copy. Oh yeah, I remember this command, which uses SSH, secure shell. Yeah, secure shell to transfer files in the Docker server type. Secure copy, SecServer colon home user ca mm, space or no space? We will see without space. CRT registry key registry CRT certs. Let's see if this is okay. Secure copy as cipher F SS config I identity file J destination L limit O option P port. Is that okay? Okay. Wait, so here should be the okay. I will redo it and I will check it again. SecServer colon home user ca cert registry key registry cert certs. Okay, certs. Come on. Now? Yeah. CA cert registry key registry. Okay. You now have a new configuration and all the required files on the Docker server machine. The container must be restarted with the new configuration to make it effective. This will take a few steps. Okay. Sudo docker container stop registry con con okay, type pet run with transport layer security sh sudo port 500 v version home registry. The docker command has multiple arguments. Run, create a new container and run it. Slash I didn't use the it's here. D, run the Docker container detached, P, expose port 5000 of the Docker container on port 5000 of the host. Version mount host directory home user certs from the host, add certs in the container. Mount the host directory. Mount the new configuration. New configuration, registry, data server, and here mount the host directory. Name registry. Set the name of the created container. Registry, the name of the image. Type run with TLS error. Uh-oh. What's now? Already in use. So, well, I followed all the commands. Uh, Docker PS A. Docker PS. PS A. Ah, wait. Oh, okay. Because my command was PS hyphen A. Permission denied. Okay, sudo Docker PS A. And it says that in perfect. Now you see container registry name image status existed stopped but still exists. Sudo docker rm remove registry. Now try again. Sudo docker rm registry. Sudo docker rm registry. Hyphen. No, hyphen. Uh-oh. Hmm. Registry. Mm, okay. Okay. Now you need to set a Docker runner to use mutual TLS to connect to the registry. On the virtual workstation desktop, double-click command prompt to open a new command prompt. Type SSH Docker runner sudo Docker pull registry 5000 alpine password. Uh-oh. Oh, okay. That's the plan. I should get the error. You should get an error. Okay. The registry. Um, the registry then responds with the certificate that was generated for the server. However, the Docker engine on Docker Runner does not yet know about the certificate authority used to sign the certificate. It issues an error to the certificate to an error that the certificate is signed by an unknown authority. Make a screenshot. Wait. Let's start screen. Type sudo make directory at docker certs d registry file. The Docker engine allows you to specify certificate on a per registry basis. Each registry can have a folder under ads docker certs d. Inside that folder, any certificates that end with .crt will be trusted as certificate authorities. Secure copy SecServer home user ca ca cloud one g cloud one cert. Is this okay? Wait. Mm-mm. Let's see. SecServer home user ca third cloud one e cloud one. Okay, I see. Space. Now Here, it's hard to say if it's space or not. Okay. Sudo copy CACRTF Docker certs D registry 5000. Okay, that installed the CA certificate. Sudo Docker home registry 5000 alpine using default tag latest error response from daemon. Should I get an error? New error. This time it is because you have not yet specified your client certificate. This is okay. So do copy cloud one 30 at Docker certs D registry 5. Oh, did I do something wrong? Cl- cl- cloud. Okay. Type one registry. Error. Finally succeed. Uh-oh. Oh. 10. This is the fifth screenshot. 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 At this point, you have configured the registry on Docker server and the client on Docker runner to use mutual TLS for communication. Both machines rely on the certificate authority identified by the same certificate CA cert that was generated in part 1. This will reject clients without a valid certificate signed by a certificate authority cert. The client will connect to registry 5000 only if it has a valid certificate issued by CA. Logout. Exit. The example architecture you are using has a front-end server and a back-end server. In this lab, there will be a single instance of each running in a container. One of the main reasons to divide a web service into two parts like this is for scaling. The back-end server is responsible for generating pages based on user requests. Sometimes that process can be relatively slow. However, it is often possible to cache the results if they do not change frequently. The front-end server acts as a primary interface for end users. In cloud environment, it is possible to achieve a similar configuration. Most cloud providers give means of creating a virtual private network within their own cloud. Give means of creating a virtual private network. Okay. However, mixing different cloud providers into the same virtual network is more difficult. By using this method, you are also placing more trust in the cloud providers. Zero Trust model uses an architecturally simpler configuration. No special networks. Networks need to be set up between the front end and the back end servers. Each server simply needs to have an address that is accessible on the public internet. Because the access is open, all communication needs to be authenticated. For your testing scenario, your team has created a simple web application to produce a single test page indicating the nature of the connection between the front end, the backend, at the back end, the backend servers. The front end server is using Nginx. The first step is to build Docker image for the backend server. Okay, SSH. Oh, build too many arguments. No space. Okay. You will build Docker images and push them to the registry. The folder build backend contains source code and a Docker file backend. Head and backend Docker file. From registry 5000 golang as build work directory compose hello docker copy main go run cgo enabled zero go build cmd. Work there set working directory inside the container. Copy main go copy your go source file into the container. Run cgo enabled zero go build -o backend main go build the go program with cgo disabled output binary named backend from scratch. Start a completely empty image. No operating system. Copy from build compose hello docker backend. Copy the compiled binary from the build stage into the final image. Okay. 1 to 5 instruction for building. Golang. 7-8 create a new image. 7-8 create new image from registry. Okay. Okay. Sudo docker build t registry 5000 backend password sudo password sending build context to Docker daemon pool already exists. Digest, download newer image, compose, removing intermediate container, copy, steps, running, removing intermediate from scratch, copy. The Docker build subcommand can be used to create images using a Docker file. The other arguments are registry backend sets the tag for the resulting image. Backend is the folder containing the Docker file. In the Docker rudder session type sudo docker push registry 5000 backend. The push refers to repository. Pushed. Explain. Docker finished building your image and its internal ID. Successfully tagged registry backend latest. Here, successfully tagged. Sudo docker push. You push the image to your private registry. Default tag is latest. Since you didn't specify another, the push refers to repository, confirms where the image is going, pushed, upload, succeeded, and the registry stored your image. A unique cryptographic hash of the image content guarantees integrity. Size 528 compressed image size in bytes, 10 to the to the power of 3, uploaded to the registry. You build a Docker image locally, tagged it for your private registry, and then successfully pushed it so others or your cluster can pull it from registry. Type cd. We have engines here. The next step is to create and run containers. To emulate this, the containers will be run attached to the host network. -D to run detached network host to use host networking. Name backend to set the container name. Registry 5000 backend is the image identifier. Okay. Backend SH. Nginx. This file configures Nginx as a reverse proxy. Listen 80 Nginx listens on port 80 HTTP location proxy path backend port 80 8080 forward requests to the backend service on port 8080 proxy set header X front end server scheme add a custom header showing the front end server info proxy set header X backend server add another header to show which backend handled the request and Jinx listens on port engine Nginx engine X engine X is a high performance web server that can also act as web server serves static files like HTML, CSS images. Reverse proxy sits in front of backend apps and forwards requests to them like in your config. Load balancer distributes traffic across multiple backend servers. SSL TLS terminator handles HTTPS encryption so backend apps don't have to. IPA gateway can add headers, filter or route requests to microservices in simple. This is like a smart traffic cop that takes requests from users, browsers, APIs, decides where to send them backend services, can optimize speed, security, and reliability. It creates reverse proxy. Oh, now it's 9080. Lines 5 and 6 set custom headers in the request from the front end and the back end that are used by the test application. Run now front end. Enable. Oh, okay. That was planned. Since the Nginx image was not yet on Docker Runner, it first pulls it from Docker server. Now you should confirm that the containers are actually running. HTTP 172.31.020. Oh, click on the hello from the original server, no TLS context for request. You should see a page. Hello. Make a screenshot. Click the origin. Hello from the origin 7.ts. Okay. Type secure copy SecServer home user ca cert backend cert backend key backend certs server user ca cert backend key space. Okay. Head and run backend TLS SH network host environment app CA certificate name backend registry. V means mounting. The command is very similar to the original one with the addition of several environment value. Arguments to set environment variables as well as a volume to mount the certificates folder into the container. The application is designed to use these variables to find the certificate and key files when running with TLS enabled. Note that the container is given a different name as well. Front end key front end certs. Okay, and here it will be a space. Cool. Okay. And run front end TLS SH. Really? front. Mm, How about now? Mount default configuration, mount certs, add host backend, name front end, transport layer security, registry. Okay. So the Docker container stop front end back end run back end TLS sh run front end TLS sh. Hmm. Click the origin HTTPS. No valid client certificate given. Oh, okay. Mutual TLS for development machine. The developer machines will need to be able to talk to registry with mutual TLS as well. Use the certificate authority to set up SecServer to create a new client certificate with a distinguished name. Configure the Docker engine on SecServer so that it can communicate with the registry on Docker server. SSH SecServer. dev CSR CA cert CA key CA key CA create serial out dev cert base 365 shed 256 showing at least the first at least make a screenshot showing successful pull of registry. Okay, it's sudo docker pull registry 5000 alpine password error. Okay, sudo make there the registry 5000 sudo copy dev cert dev key cert at docker certs the register 5000 restart the docker restore docker sudo docker pull registry 5000 alpine missing client sudo make clear p at docker search the registry 5000 docker search the registry 5000 CA cert sudo copy dev cert at docker search the registry 5000 client cert sudo copy dev key adds docker certs the registry 5000 client key. Restart docker and let's do it again. Sudo docker for registry 5000 alpine. Sudo remove rf at this docker certs the registry sudo remove p at docker certs the registry 5000 sudo copy ca cert at docker cert the registry copy 5000 cert sudo copy dev cert at the same docker search the registry 5000 client cert sudo copy dev key at docker search the registry line key sudo system start docker sudo docker for registry 5000 alpine open verify assert dev Cert. Woohoo!